Hello everyone, happy to see you here. Today we have really interesting Olympiad question, x to the power 3 equal to 3. We need to solve this question for x, so if you have your solution, your answer, you can also write it in the comments below. It will be really interesting to read about your solution, and of course we will check our answers in the end of the video. So let's start. First of all, let's rewrite this expression. So x to the power 3 is equal to 3. And there are a lot of ways how can we solve this question. My way, I use this really important trick. I just raise both sides to the power 3. So let's start with this really tricky move. So let's raise both sides to the power 3. As a result, on the left side, we have x to the power 3, and of course raised to the power 3, and equal to 3 to the power 3. I don't want to raise it. This is equal to 27, I guess. Yeah, but I don't want to raise it. And right now, let's look closely at this expression. First of all, I want to underline really interesting moment, really important property. This is the most popular property. Everyone knows about this property. It looks like that: a to the power x raised to the power y is equal to a to the power x times y. Everyone knows about it, but in the same way, there is really interesting thing about this property, because we can write it as a to the power y times x. Yeah, this is multiplication, so we can easily change these x and y positions, and as a result, from this side we can write this a to the power y raised to the power x. And if we look closely, in the beginning we had x inside parentheses, y outside, and in the end we have y inside and x outside. So basically we can easily change this y and x by each other, by this position. Yeah, so let's do it. Let's rewrite this equation from the beginning. So x to the power 3 raised to the power 3 and equal to 3 to the power 3. And right now let's look closely at this expression and let's use this property. First of all, we have our base x, and we have power x cubed, and we have 3. So we have two powers. This is inside and this is outside. Basically, we can see this example. We can easily change this power's position. So if we call this as a and this power as b, we can easily change this a and b by positions, okay, according to this property, because yeah, we can easily use this property everywhere. Yeah, so let's do it. So we have x to the power, what power, but we write this 3 inside parentheses, and outside we write x cubed according to this property, as I said before. So according raising to x cubed equal to 3 to the power 3. So I really hope you understand this tricky move, because this is maybe not the fastest way to see the solution, but this is a tricky way, so that's why it's really interesting and really important you to understand what I mean. And right now, really easy thing, because we have the same base. So if we call this x cube, for example, as a, and this x cube is also a, so basically we have a substitution, x cube equal to a. Okay, so let's do it. So let x cube is equal to a. So basically we have really interesting exponential equation. It looks like that. So we have a to the power a equal to 3 to the power 3. And after all these steps, we have really interesting exponential equation, a to the power a equal to 3 to the power 3. And I hope you understand that a is equal to 3 because we have the same base and we have the same power. So a to the power a equal to 3 to the power 3. Only one case when this equation had the roots is a equal to 3, but basically we can solve it according to Lambert W function. If you want to see this full solution, I have a lot of questions on my YouTube channel. But according to this one, we write that a equal to 3, and let's go back to a substitution. So x cubed equal to a, so we can write but x cubed equal to a. So as a result, we have x cubed equal to 3. So from here we have x cubed equal to 3. And of course we can easily apply the third root on both sides. So as a result, our x is equal to cubes root of 3, and this is our root to this question. Okay, let's check it. So we have x equal to cubes root of 3. So let's check it. So let's check. So we have x to the power 3 is equal to is equal to, we have 3. So let's plug in this cubes root of 3. So we have cubes root of 3 to the power cubes root of 3 and raised to the power 3 equal to 3. Okay, so cubes root of 3 to the power 3. So let's start, for example, with this expression. Yeah, cubes root of 3 to the power 3 equal to cubes root of 3. If you're talking about simple words, or cubes root times cubes root of 3 and times cubes root of 3. This is a long way, but in the same way you can also use it. But the best way is to cancel this, because cubes root of 3 equal to 3 to the power 1/3, and 3 to the power 1/3 raised to the power 3 equal to 3. So basically we have another branch. This is equal to 3 to the power 1/3 raised to the power 3 equal to 3 to the power 1, because 1/3 times 3 equal to 1. So this is equal to 3. So let's rewrite this expression. So we have cubes root of 3 to the power 3 is equal to 3. So we have the same expression once more. We have the same expression as right here. So 3 to the power 1/3. So we can write it as 3 to the power 1/3 raised to the power 3 equal to 3 to the power 1/3 times 3, and of course equal to 3, because this power is equal to 1. And this is my solution, to this question. But few thoughts about this question. If you're really interested in notes about this question, so in the previous step we write that x cubed, where do we have it? X cubed equal to 3. So basically, if we write this equation x cubed is equal to 3, if we write this equation right here, everyone knows that x equal to cubes root of 3, so we wrote it before. But in the same way, x cubed equal to 3 can also have like one real root, as I said before. But basically, this x cubed equal to 3 can also have like two complex root. So this is not a full solution in terms of everything, in terms of both real and complex number. This is a solution in terms of, so our answer x equal to cubes root of 3, but this is our real number root. So if you want to solve this question completely, you just have to find these two complex root in this branch. Okay, x cubed equal to 3, because if we draw a graph right here quickly, if we draw a graph, everyone agrees that x cubed we have something like that, and x equal to 3, y equal to 3 we have something like that. So basically we have only one real number root. But in the same way, according to a fundamental theorem of algebra, we can have right here two complex roots. So that's why if you solve this question for x second and x third, so right here we have x first is a real number, and we have x second and x third are complex numbers. Okay, so if you want to solve this question completely, you just have to solve this for complex number. But we are interested in a real number root, so that's why x equal to cubes root of 3. This is only one real number root. And I find a graph for you for this question. So if you want to draw a graph according to this question from the beginning, so it looks like that. We have right here 3, and we have something like that. I draw this approximately because not a lot of students, they interested in a graph, so something like that. And right here we have our cubes root of 3, so only one point of intersection. Yeah, but according to complex numbers, you need to solve this branch, and we will have three roots in total, according to a fundamental theorem of algebra. Okay, so this is my solution to this question. I hope you understand it. I hope you learned something new, but definitely don't feel bad if you got this wrong. If you need help with any of these classes, I have a lot of questions on my YouTube channel, a lot of different type of questions. So I really hope you understand, and I really hope you enjoy this solution. Write your response in the comments below. What do you think about this solution? Maybe you have your tricky methods. How can we solve this question? It will be really interesting to read about it. And yeah, of course, don't forget to write maybe your question. If you want to see a different type of Olympiad questions on my YouTube channel, it will be really interesting to solve this question. If you have a question that you don't know how you can solve it, so you can also share this question in the comments below. It will be really interesting to read about it in the comments below. Higher mathematics, algebra, Olympiad question, geometry, and doesn't matter. It will be really interesting to read about these type of questions. So yeah, this is my solution to this question. Thank you for your time. Have a great day and see you in the next videos.